So 482 alpha. State and check the conditions. Well, we've been doing conditions. Confidence interval, that's what we did in 8.1. These are confidence intervals specific to proportions. And then work backwards and find the sample size if you already know how confident you want to be. So look at this thing. This is a confidence interval of C%. What is going on here? The confidence interval is built around p hat. So you take a sample proportion and then you build a confidence interval around that statistic. But depending upon how wide the confidence interval is, you are whatever level of confidence you have, you capture the true parameter. So how do you do that? P hat plus, ready? Here's the standard error. What is it? This is in chapter 7. This is on your test on Monday and Tuesday. P hat success times 1 takeaway P hat failure divided by n, which is what? That was a size change of 1 over n to the binomial step. Now what are we doing? We're multiplying that. That's one standard error. That's one standard deviation from chapter 7. We're multiplying that by z. What's our z-score? Well, the default z-score, which we saw in 8.1, if we want a 95% confidence interval, then the default z-score would be what number did we use yesterday? We want to capture 95% of the population. Use 1.96. Why? Because we say the empirical rule says 2 steps. You can't see this if you're not, but here's what we're doing. This is what we've been doing all semester. What did we tell you before? That one step left or right of the curve captures 68.26% of the population. And empirically, we say 2/3 of the data is within one standard deviation of the center. So now what? If we go out to 2, the empirical rule says we capture 95%. Yes? But if we're more precise by using inverse norm, this isn't really 2. To be more precise, it's 1.96. The negative 1.96 for z-scores. 95% is the default. You can have other confidence levels. Like, for example, when we looked at the polling, which we didn't spend a lot of time doing because we weren't far enough in the book. But if you look at polling regarding the election, and it said the blue candidate is polling at 49%, add or subtract 2%. The red candidate is polling at 45%, add or subtract 3%. Saw this stuff. That's the margin of error. This is a statistical tie because it's a 95% confidence interval. They didn't put that in the paper. That means this character is going from 47 to 51%. They're 95% confident that the true proportion of voters are going to pick the blue candidates in there. This means the red candidate is going from 42 to 48%. Yes? But because these overlap, it's a statistical tie. See, this 48% at the end, this one doesn't, all of this isn't above that one. So for somebody to be winning, they have to, all of their confidence interval would have to be above this one. But they didn't even win the confidence intervals when you were looking at the polling, they just gave you this information. So what do? This Z asterisk will be 1.96 if it's a 95% confidence interval. So what are we doing? We're taking P hat and adding, not one standard deviation, 1.96 of them. You get the width of the confidence interval. And then you have the conditions. What are going on with the conditions? You have to have an SRS. The confidence interval is not going to help you if you had bias in your data collection. Large counts. Ready? The large counts for proportion is saying n times p hat is greater than or equal to 10. N times 1, take away p hat is greater than or equal to 10. That's how you be confident that the distribution, the sampling distribution, is approximately normal. And then you don't want to have your sample be more than 10% of the population, because we are sampling without replacement, and the algorithm is based on with replacement. So we're going to change the name from standard deviation to standard error. Not a big deal. Okay. The standard deviation, right, refers to the parameter. The standard error is telling you it's a statistic. So here's an example. You want a confidence interval in the true proportion of red beads. So they took a sample, 251 beads, and they got that. Okay, it was a random sample. Condition. Next thing. Less than 10% of the population. We're good because, ready? You're not putting the beads back in. And you're greater than or equal to 10. So you expect it to be Gaussian normal. This picture is what's on the board. So you can't see this at your home, but that's what we drew on the board. If, see this Z asterisk? We know what that number is. It's 1.96. How do we know that? Because it says on the Google slide that the area to the right of it is 2.5%. So the area to the left of it's 2.5%. So the unshaded area in here is 95%. So what did we do yesterday? Yesterday we did inverse norm. In fact, take out your calculator right now. Sure you can do it. Then we're going to go to second distribution. Inverse norm is 3. You there? Where it says area, you got to listen. This side of the row is going to put 0.975 in for area. This side of the row is going to put 0.025 for area. You understand what happened? It doesn't matter what you did. If you put 0.025, you said, give me the z-score for this part right here. Does that capture the first 2.5%? So you would have gotten negative 1.96, correct, Nick? Yes? If you put 9.725, you're over here. Everything except that 2.5%, you would get positive 1.96. It doesn't matter because the graph's symmetric. You can pick the negative one if you want it. You can pick the positive area if you want it, whichever you're more comfortable with. You got to be careful here. See, this is the default. It's a 95% confidence interval. But we can have 90% confidence intervals. We can have 99% confidence intervals. And then we'd have Z asterisk would be a different number. Well, how do we know it? We would use inverse norm on the calculator. See, there is no non-calculator part of the AP test. But you have to understand how to operate technology. So this says use the table. We could do that. We can go to the table in the back of the book, and you're getting a table in the formula sheet in May. But I don't really remember anybody in this room over the last 12 and a half years that prefers the table to the calculator. So here's the command which you just did. Ready? They're saying area 0.025, which is what the people over on this side of the room did. That's how they get the negative 1.960. So they say Z asterisk is 1.96, which is right or left. But if you put 0.975, you would get the positive value. So look at this one. Ready? 73% of American adults have read a book in the previous 12 months. Ouch. Assume the conditions are met. So you don't have to do them this time. It tells you they're met. Determine the critical value. It's a 90% confidence interval. Go ahead. What are you going to type in on inverse norm? You want a 90% confidence interval. You would get 1.645 to the right or left. Yes? You either do inverse norm. You got to think about this. The graph's symmetric. So if there's 90% in the middle, there's 5% in each tail. So you put 5% in there or you put 95% in there. So if you're not listening, ready? Here's what people are going to do. Oh, it's 90%, so I'm putting 90 in there. If you put 90 in there, what confidence interval will that give you a Z-score for? %, confidence interval. Because if you put 90 in there, that's saying you're leaving out 10% on the right. So you'd be leaving 10% on the left. So there'd be 80% left in there. So that's what you have to anticipate. That what you type in inverse norm doesn't correspond to the confidence level, because inverse norm gives you the Z-score counting all the way to the left. And the confidence interval is based on the center of the curve. Here's the step. Does this make sense? 73% is P hat. This is your critical value now because you're at 90% confidence interval. Success times failure over the sample size. Yeah, right? There's two ways to write this. You look at this. You could write 73% add or subtract this value, which is about 2%. You good? Or you can write it with the parentheses, 71 to 75%. And again, don't worry about this. The parentheses don't mean the same thing they do in calculus. We don't need to write brackets to say it's inclusive. It's understood to be inclusive. Okay? Interpret the value. That means this. We're 90% confident that the true proportion of Americans who have read a book in the past 12 months is between 71 and 75%. It doesn't mean it's a 95% probability. That's what we did yesterday. We're 95%, I'm sorry, we're 90% confident that the parameter is in that interval. Right? Okay, so we're going to do an inverse norm problem here. Ready? So if I wanted a 90% confidence interval, I would go here. Second distribution. Inverse norm. So if I want not ready, now this is the newer calculator. I don't really want to deal with this. So you could do this. If you have the older calculator, it's going from the left. You don't have this option. If you have the newer one, you can play with this. It's getting you left, center, right. So it would give you this, yes? But not everybody has this, so we're not going to do that. We're just going to do the default from the left. So the area under the curve, if it's a 90% confidence interval, means there's 10% missing. 1 take away 90%. And the graph's symmetric, so that means 5% in each tail. So if I type 0.05 here, where the center is 0 and the step's 1, here's your critical value. Or, that's on the left, or I can make this 95%, and I get the number on the right. But see, you don't have to do it twice. It's going to be symmetric. You do it once, and you just change the SIG in. Okay? So, the first thing, ready? The conditions. The conditions are SRS, the sample is less than 10% of the population, it's a proportion. So for you to assume that the distribution is approximately normal, n times p hat, n times 1 take away p hat, they both have to be greater than or equal to 10. Now, just so you understand, you're looking at that PDF, I'm having some issues with the hat showing up, like converted from Word to PDF. There's a hat. A hat means it's a sample proportion. The template. Here's what you have to do. All of this. The parameter, what you're trying to study, the conditions, the null and the alternate, which we didn't get to yet, the test statistic, reject or fail to reject with a reason. Now, you don't need to write that down because this document is in Canvas. It's in the Chapter 8 folder. It's the inference template. And once we get really into Chapter 9, I use this to do the homework. So you'll be used to it. But if you get an inference problem, inference means they want you to analyze this data. On the AP test, you're expected to do the entire template. Now, last year, here it is, there's the template. Parameter, just like they said in the book, the parameter of interest. What am I trying to find? What am I trying to be confident about? What's the test we're doing? Well, in this case, it was a whatever percent confidence level interval. Confidence interval 95%. Conditions. SRS, n times p hat's greater than or equal to 10, n times 1 take away p hat's greater than or equal to 10, and my sample's less than 10% of the population. We didn't get to the known alternate yet, so I'm not going to worry about that yet. But that's in there. And really what's going to happen is, if this isn't academically dishonest, if we have an AP test like we did last spring, you have a hard copy of this when you do it. But you can't, maybe we won't have that test. And you have to do the, if you're doing a sitting, you have to know what these prompts are, but they're not going to give them to you. So, you're going to go to 2 questions. We're going to pause the video, and you're going to go to problem 35 and 37. And we'll come back to those. So we're on question 35B. How to construct the confidence interval with the technology. So we are at stat test. So stat test, drop down to A. And it's intimidating, this menu, because you have all these choices. But it's kind of like CDF and PDF. You see these are paired up with Z's and T's. We didn't get to T yet. So everything's going to be a Z. So if we push 1 proportion Z interval, here's the command. What out of what? And he asks for the confidence interval. So it's kind of done for you. So in this case, we had 914 is success out of a sample size of 4579. And they wanted a 98% confidence interval. Does it for you? Makes sense? It's telling you the confidence interval goes from 18.5% to 21.5%, basically, which is what we have here. %. See, this is the center. Add or subtract 1.4%. That's one way of writing it. And that confidence interval, just giving the endpoints, is another way of writing the same thing. So what does that mean? It means you're 98% confident that the parameter's in there. So, if you are at home, you are dismissed to do the exit ticket. If you're at home, you're taking the test on Monday. Your resource for that test are the AP practice test for Chapter 7 in Canvas and the textbook with the solutions are in Canvas and your review. Have a nice weekend. If you're here, we're moving on to 37. So 37 says, calculate the margin of error. What does that mean? It means this. That we had, what? $19.96. Here was the confidence interval. .1996 in the center. And then we add or subtracted 1.37%. But those are, that's for a 90%, 98% confidence interval. That was 2.33 standard errors. Good, so it went from 18.6 to 21.4, say, there's your confidence interval, okay? But if we put z-scores here, this is negative 2.33 z-scores, and that's positive 2.33. The standard error is 1 z-score. The standard error means the standard deviation of a statistic. We're just going to do a size change. The 1.37 was 2.33 steps. So we divide by 2.33, and this is telling us here the standard error would be 0.006. That make sense? The standard error is 1 step, left or right. The margin of error is after you do a size change of that step that reflects what confidence level you want. So